Hello, welcome viewers and welcome learners to this presentation where I want to take you through the 2016 grade 12 paper 1 specimen. Okay, as you may be aware, the syllabus was reviewed and then the first intake under the new syllabus wrote the exam in 2016. So before the actual exam, ECZ sent the specimen of how the new exams would be formulated, and this was the paper that was sent as a sample. Okay, this was the paper that was sent as a sample. Okay, so this is the paper that contains the questions that I want to take you through. All right, so please can you pay particular attention and do not forget to subscribe, do not forget to share, do not forget to comment and like the presentation. Okay, so let's start with the first question. This question came from algebra and we are required to simplify. Simplify 5 open brackets 2a minus 3b minus 6a minus 2. So how do we simplify this one? That is very important. Okay, by the way, this is my name. Okay. And this is my phone number. Alright. So just in case you may need those details. I'm a teacher of mathematics at Rimbayanga Secondary School in Lusaka. Okay? So let's begin. So how do we simplify? How do we simplify here? We need to get rid of the brackets first. We get rid of the brackets. Okay? So to get rid of the brackets, we need to multiply here. 5 multiplied by 2a. What are we getting? We're going to get 10a. Okay? Minus 5 multiplied by 3b, we are going to get 15b. Then we come to this other part. Take note because of this one here, the minus that we have here. It's as good as saying we have a minus 1 here. So take note of that. Then we need to distribute. So when we distribute, we're going to have minus 6a, and this minus will give us plus 2. Then at this point, we need to put the like terms together. And that is going to be 10a minus 6a minus 15b, okay? Minus 15b, then plus 2, okay? That is what we are supposed to do. Then after we have put the like terms together, the like terms that we have is this one and this one. So we're going to get 4a minus 15b plus 2. This is what is going to be our final answer. Simply because we cannot either subtract or add unlike terms. And these are unlike terms. So this is what we're going to have. Okay? This is what we're going to have. So allow me to take you to the next question. This one here. We are being asked to find the cube root of 64. The cube root of 64. If you are using a calculator, it's very easy to tell. Now remember that paper 1, you are not required to use a calculator. So a cube root of 64 is what number do we multiply by itself 3 times in order to get what? In order to get 64. And you're going to discover that that number is 4. I mean, it's 4. That is what you're going to get. So the cube root here is 4. So the cube root is 4. And then that 4, we need to square it because of the square here. Okay? The cube root is 4. Then squared. This is 4 multiplied by 4. 4 squared is 4 multiplied by 4. And that gives us what? 16. So 16 is our answer to the second question. Alright? So then we move on to the third question. Find the gradient of a straight line passing through these 2 points. Now, remember that gradient is represented by the letter M, and the formula that we use is y2 minus y1 over x2 minus x1. Okay? This is the formula that we use. And let us assign this, so this is going to be x2 and this is y2. This is the y coordinate from the first point, so it is y1, this is x1. This is the x coordinate and this is the y coordinate. X coordinate, so we begin now to transfer. y2 is 5 minus y1 is negative 6 over x2 is 8 minus negative 2. Okay, so I'm just getting those coordinates as they are and throw them into the formula. Then we proceed and say this is 5 plus this is 5 plus 6. Then here we have 8 plus 2. And this is going to give us what? This is giving us 11 over 10. So our gradient is equals to 11 over 10. Or we can divide and make it a fraction. But in most cases, this is what we use. Okay? This is our gradient here. This is our gradient. It's basically that what you are supposed to do. And this is what you are going to get. Remember, we are going to solve the whole paper, so I'm taking you step by step. And I'm sure you are familiar with these things we are revising just together. It's very important to approach mathematics in that manner. Okay? When you just go straight to revisions, you're going to think that things are difficult when you just don't have the basic knowledge. Alright? And now let me take you to question 4, where we are supposed to factorize. And from our factorization lessons, okay, our YouTube channel has all the lessons from grade 10 up to 12. From the lessons that we presented, we discussed 4 methods of factorization. So we need to identify which method of factorization is applicable here. So first of all, when you look at 3 and 27, 3 can go into both numbers. So we have 3x squared minus 9. Okay? We have factorized. And here we have used the common factor method. Now when we come to the second part, we have to think of another method that we can use to factorize this one, if at all we have one. And the answer is yes, we can factorize this one using a difference of 2 squares. So what are we supposed to do? We need to rewrite this one. We need to say 3x squared minus, okay, we write this 9 as 3 squared. Why are we doing this? We want to achieve a difference of 2 squares. 2 squares, a difference of 2 squares. Once we have a difference of 2 squares, how do we factorize? So we're going to have 3x plus 3 or x minus 3. This is what is going to be our final answer. Are we together? This is what is going to be our final answer. So let me take you to question 5. Come to question 5. On the Venn diagram in the answer space below, shade the set. Okay, shade the set. So we have 2 sets. There is this set here. Okay. this set here. Where is this set? Okay, so if I can just take an example, if we have these two sets here, we have A and B, then we want to shade this set, just this, okay, where we are looking at these two sets. We are saying what is not in A but is there in B, so it's this part here, okay. That is it. Just for this part alone, I'm still dealing with this part alone here. Okay? I'm still dealing with just this part. So meaning, we are looking at this whole part here. You look at, we are looking at this whole part here, which is B. B as a whole circle. I mean, as the whole set here. This one that I've shaded. Look at it in this diagram. Okay? Then, this part that we have shaded here, take note there is now C. This part that we have shaded, intersection C, okay? What is common between this one that we have shaded and C? So it will only be this part here. It will only be this part here. So when it comes to this one, what will be shading is this part here. What will be shading is this part here. Okay, this is what we're going to be shading. All right, then we have question 6. Given that M is given by this matrix, N is given by this, express Mn as a single matrix. So we are multiplying these two matrices. We are multiplying this matrix by this one. So we can even multiply straight away, although it's advisable to write them here, but we can multiply straight away. So how do we multiply? We multiply row by column. So 4 multiplied by 3, what do we get? 12. 1 multiplied by -1, what do we get? -1. 3 multiplied by -2, what do we get? -2. Are we together? This row by this column. 4 multiplied by -2, we get -8. 1 multiplied by 4, we get +4. 3 multiplied by 0, we get 0. Come to the second row and each column. 2 multiplied by 3, we get 6. -5 multiplied by -1, we get +5. 4 multiplied by -2, we get -8. Second column, 2 multiplied by -2, we get -4. -5 multiplied by 4, we get -20. 4 multiplied by 0, we get 0. Are we together? So we can work out these. This is going to be 9 here. This is 11 minus 8. What do we get? We get 3. Here, what do we get? We get -4. Here, what do we get? We get -20. That's what we're going to get. Okay. We come to question 7. For the sequence 11, 14, 17, 20, find the 15th term. So for the nth term of an AP, we use the formula Tm is equals to A plus, this is the first term, this is the common difference, N is 15. So common difference, which is D, how do we work it out? Second term minus first term. So when we subtract here, what do we get? We get 3, isn't it? So our D is 3. 15 minus 1. What is our first term? 11. 11 plus what do we get? 14 multiplied by 3. So before we add, we need to multiply. So this is going to give us 11. What do we get here? This gives us 12. So this is going to give us 42. So 42, when you add, what do you get? This gives you 53. So meaning the 15th term is 53. The sum of the first 20 terms. So here we use the formula n over 2a plus n minus 1d. This is the formula that we use. Find the sum. So 20 terms. So when we say 20 here over 2 multiplied by 11 plus 20 minus 1, then multiplied by 3. This is going to give me 10, 22 here, plus, okay, plus I'm going to get what? 19 multiplied by 3. So I have 10, then 22 plus 19 multiplied by 3. We get 57 here. 57 plus 22. What am I getting? 10 multiplied by 79. So when I multiply this one, it gives me 790. And that's what I'm going to write here, 790. This one we got 53. So we come to question 8, which is on sets. Given that the number of elements in the universal set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P is 2, 3, 5, 7. Q is 2, 5, 8, 9. Find the number of elements that are members of this set. Okay, so we are talking about we're talking about P intersection Q complement. Okay, so we are talking about the first of all, let's look at the intersection. Elements that are found in these two sets. Elements that are found in these two sets, what are they? 2 is here, 5 is here. So it's 2 and 5, isn't it? It's 2 and 5. It's 2 and 5. So meaning, when it comes to this one, 2 and 5 must not be part of the answer. We do not want the intersection of these two. So we're looking at 1, 3, 4, 6, 7, 8, 9, and 10. This is what is going to be our answer. And these are the elements that we need to list down here. Okay. Then we go to the next question. It says, a plan of a house is drawn to a scale 1 to 20. If the actual area of the ground floor of the house is 80 meters squares, calculate its area on the map in square centimeters. Okay, so this is what we're supposed to do. So we say 120. Okay, this is on the ground. Then so this is a measurement on the map representing 1 centimeter on the map represents 20 centimeters on the ground. Okay, so if the actual area of the house, the actual is this one. So we're going to put X here and say here we have 80 meters square. Now, take note that here we have centimeters and these centimeters are not squared. So we need to make sure that we have a common unit here. So let me start from here. We're dealing with here 1 meter is equals to 100 centimeters. Are we together? So 1 meter squared is equals to, we multiply this one. We square this side also. What are we going to get? Am I right? 1, 2. So we're going to have, okay? So 1 centimeter square, 1 meter squared is equals to 10,000 centimeters square. So this is what we're going to do. So we're going to multiply this one by 10,000 so that we change the unit from meter square to centimeter square. And to do the same thing also here, we're going to square. So we have 1 over 400. When you multiply this, this is going to give you 400 x. When you multiply this 10,000 by 800, what do you get? This will give you this is what you're going to get, isn't it? At this point you cross multiply. You have 400x is equals to 800,000. X is equals to 800,000 divided by 400. So you knock out these 2 zeros and these 2 zeros. What do you get? You are going to get 800 centimeters. Oh, sorry. This, we knocked out the 0, so this has to be divided. We ignored these. So 4 into 8, it's 2. So we are supposed to divide. This is going to give us 2 centimeters square. Okay, take note of that. So this will be 2,000 centimeters squared. Okay, then here we needed to list those elements. 3, 4, 6, 7, 8, 9, and 10. Okay, this is what we're supposed to do here. Let's go to the next question. Okay, so question 9. This is question 9a. When time is 08 hours at A, it is 15 hours at B. What is the difference in longitude between these two? Okay, what is the difference in longitude? When time is 08 at A, it is 15 hours at B. What is the difference in? So we need just to find what's the difference in hours here. We find the difference in hours. You can say 15 hours minus 08 hours. What are we getting? Okay, let's subtract. What are we getting? This is going to give us 7, isn't it? It's like now we're getting 7 hours difference. Okay, 7 hours difference. Now, so the difference in time between these two places, it's 7 hours. But here we're told, what is the difference in longitude between these two places? So 1 hour is equals to 15 degrees. So we multiply 7 by 15. What do we get? 105. Isn't it? Just confirm. So this is going to give us 105 degrees. So that is what we get, 105 degrees. Okay. Find the distance between A and B in nautical miles. Find the difference. So if you want, we can sketch just to have a clear picture. So this is 30 degrees north, then this is 45, so this is our A here. This is 45 degrees east, then B is here 60 degrees south, and then the same. So find the distance between A and this point and this point in nautical miles. So usually when we are finding the distance in nautical miles, we say theta multiplied by 60. Okay, so here we are talking about what is the theta is the difference in latitude between these two places. So this is the north, this is south, so we add them. We are adding because they're in two different hemispheres to find the difference. So we get 90 multiplied by 60. So let's multiply 90 by 60. What are we getting? Let's multiply 90 by 60. We're going to get 5,400 nautical miles. Okay, this is what we're going to get. Okay, let's see the other question here. Okay, let's see the other question. Quiz questions are numbered from 1 up to 20. A question is selected at random. What is the probability that the number of the question selected is a perfect square number or a prime number? Okay, so first of all, we need to find the perfect square numbers between. What are perfect square numbers? The perfect square numbers, okay? The perfect square numbers. What are those perfect square numbers? We're talking about those numbers that have square roots, okay? We're talking about those numbers that have got square roots. So between 1 or from 1 to 20. So those numbers are 1, 4, all right, together, 1, 4, 9, and 16. These are perfect square numbers. Then let's come and find prime numbers. How many prime numbers do we have between 1 or from 1 to 20? Prime numbers we have 2, 3. A prime number is a number that can only be divisible by 1 and the number itself. All right? So it is 2, 3, 5, 7. I don't want to skip any. Don't want to skip any. 7, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So here, from here, this one, 13. No, not this one, not this one, not this one. 17, yes. 17, not this one. Yes, this one. 19. So the prime numbers that we have are these ones here. These are the prime numbers that we have. Okay? So we start with the perfect square numbers. How many are there? They are 1, 2, 3, 4. So we say this is 4 over 20 plus, come to the other one, which is 1, 2, 3, 4, 5, 6, 7, 8. 8 over This gives us 12. This gives us 12 over 20. And this is going to be 3 over 5. When you simplify using 4 here, it's 3, 4 here, it's 5. So this is 3 over 5. Then we come to B. We are looking at question 10. Come to B. The vector position of A, the position vector of the point A and AB is equals to this. Find the coordinates of the point B. So in other words, here we're not going to waste our time. This one here, A, you must know that AB is equals to this one. And this is what has been given as what? -3 and 2. Then here, this is OA. This is a position vector, which is OA. So when we have AO, it is going to be the opposite. So it will be like 2, -1. Then plus OB is equals to this. So OB is equals to -3, 2. This one will come this side as -2, -1. So OB is equals to, this is going to give us -5, this is going to give us 3. Okay, so if we're talking about the coordinates of B, we're talking about the coordinates of B, it's these ones, these same ones here. That's what we're going to get. Okay, so if you want now, you can try to put this one here. You can try to put put this here and see if you're going to get this one. Definitely you'll get the same one. Okay, let's go to the next question. Okay, so question 11, find the transpose of the matrix here. What is the transpose of this? So you know that the transpose is just going to be A transpose. I can just indicate it here. A transpose is equals to, the rows will become columns. So we have 1, 3, -1. 2, 0, 4. That's what we're going to get. We come to this part now. The diagram below shows a sector of a circle with center O, and the angle here is 70 degrees. Given that the area of a sector is 5.5 centimeters squares, calculate the radius of the sector. So here the most important that we're supposed to know is the formula. What formula do we use to find the area? Okay. What formula do we use to find this is the formula that we use, isn't it? To calculate the area. Okay. So this theta here is the angle that is given here. So you should take note, area has been given here as 5.5. Then here we have 70 over multiplied by 22 over 7 multiplied by r squared. So we are looking for this part. Take note of that. So I can go further and simplify. 5 by 5 is equals to 7 here, it's 1. 7 here, it's 10. So I can cancel this 0 and this 1. So I'm going to remain with 1 over 36 multiplied by 22 over 1 multiplied by r squared. So we go on and say, this is easy. We can as well go further and say 2 here is 11, 2 here 18, isn't it? So we can go further and say 0.5, this is equals to 11 r squared over 18. Okay? So from this point, we can cross multiply. We have 11 r squared is equals to 5.5 multiplied by 18. Okay? So we can go further and try to multiply 5.5 multiplied by 18. What are we going to get? Okay. So this is going to be 11 r squared is equals to 99. When you multiply this, r squared is equals to 99 divided by 11. So r squared is equals to 9. The r is equals to the square root of 9. What is the square root of 9? 3. We are not going to consider a negative, so this is 9. So meaning our radius is equal to 3 centimeters. This is what will be our radius. Okay? Then we can look at question 12. Question 12a. Solve the equation. So these equations, these are equations from index notation. So we have to make sure that we make the base the same. So this is 2m minus 3 is equals to 3m. This is the same as 8. So we have 2 minus 3 is equals to 2, you multiply these two, the power rule, 3m. So once the bases are the same, then we equate the indices. So we have 2m minus 3 is equals to 3m. We put the like terms together, you have 2m minus 3m is equals to 3. This is going to give us minus m is equals to 3. Negative 1, m is equals to negative 3. M is equals to negative 3. So this is what we are getting as final answer here. Okay, let's look at the second part. Okay, so here we have a translation T maps the point 1, 4 onto 4, 6. Express T as a vector column. A translation T maps this point onto this one. So we say T plus 4, 6. Okay, so what is this? What is this? Okay, express T as a vector column. What is this? This translation here maps this point onto this one. This is the object and this is the image. So what are we supposed to do? So we're going to say 4 minus 1. What are we getting here? This is giving us what? 3. 4 minus 1 is giving us 3. 6 minus 4 is giving us 2. Okay. So basically this is T, as express T as a vector column. So this is what we're going to have here. Then here said M is equals to -3. Okay? So we got question 13 now. Got question 13. Okay, so we come to question 13, which is always on bearings. And it reads, a girl walks 30 meters from point P on a bearing. Point P is here. Okay. On a bearing of 60 degrees from point Q. Okay. She then walks 20 meters due east to R. A, using a scale of 1 centimeter to represent 4 centimeters. Using a scale of 1 centimeter to represent 4 centimeters. 4 meters. Complete the diagram in the space below to illustrate her movement. Okay? So meaning, the first thing that we are supposed to do is, we have a scale here. We've been told the first movement, okay, she walked for 30 meters. Now we are told that 1 centimeter, okay, 1 centimeter represents what? 4 meters. So we divide this one by 4. Let's divide this one by 4 meters so that we can convert this in centimeters. Can we divide that? I also want us to do the same thing for the 20, which is in meters. We also convert it by 4 meters. Okay, this one won't even give us a decimal number. This will be like 5 centimeters, because we are told 1 centimeter is equal to 4. Let's divide this one. What are we getting? 4 into 30. What are we going to get? 4 here goes 8 times. Oh, 7. 7 remainder 2. Okay. So it's 7 remainder 2. On that 2 we put a 0. So that is what we're going to get. Okay. So if I can take you back, a girl walks 30 meters from point P on a bearing of 60 degrees. So it's very important that we begin to measure here. Okay, where is my 60 degrees? Or let me put it this way. Okay. My 60 degrees, where are you? Here. Okay. That is where our 60 degrees is. Now, take note that this is the angle, 60 degrees, but then the distance from P to Q is 30 meters. That is in meters. Then in centimeters, in centimeters, it is 7.5 centimeters. Okay? So we'll be measuring now here. Together. Okay. We'll be measuring now from here. We need to go up to this angle must be guiding us here. Take note, this angle must be guiding us. So we need to go up to 7.5. And 7.5 is at this point. Okay. Okay, I have to apologize here now. Okay, bear with me. I wasn't considerate when I wrote those things there. So we draw this line. Okay, this is our Q here now. This is our Q. Remember, this angle I've been told it's then we are told that from this point here, she walks 20 meters due east. So from here going this side, she walked 20 meters. So since we have converted these meters into centimeters, so we're going to measure 5 centimeters. So just from this point here, okay, just from this point here, so okay, just want to have my 90 degree. Okay, maybe just not to mislead myself, let me have a north here. Okay, then this is going to be a good guide. I just don't want to have it okay, my other point will be this one. Okay, so this is just there to guide me. This is just there to guide me, this point. So again, here we are supposed to measure 5 centimeters from this point. Please, I apologize on where I wrote this. So 5 centimeters. So I'm supposed to write to come up to here. This 5 centimeters right here. Where my 5 centimeters is. So this is where R is going to be. This is where R is going to be. So if you want, we can actually join this part. Okay, so this is where R is going to be. Okay, so I think using a scale of 1 centimeter to represent 4 meters, complete the diagram in the space, in the answer space below to illustrate her movement. So this is what is there. Okay, then we have another question, which is find the bearing of R from P. So the bearing of R from P, we need to join these 2 points here. Sorry. Need to join these points here like this. Yes, sorry. Please ignore the one that is below. So when you look at how do we find the bearing here, considering the angles that we are given, we just need to measure this one. We just have to measure this angle. Because we know that the bearing of R from P, it is this angle here, this whole angle. Okay, so we just have to measure it. Okay, we've seen where our 60 is. This is 70, so this will be 75. The whole angle here, this is going to be 0.75. That's what we're going to get. This whole thing here, that's what we're going to get there. Okay, that's what we're going to get on this part. So we can move on to the next question. Now. So question 14 reads, given that y is equals to kx over z squared, and x is equals to 3 when y is equals to 6 and z is equals to 2. Find the value of the constant k. Okay, so here already we are using this same equation here. Take note of that. So we'll begin to do the substitutions. So y here, y is 6. Okay, then k multiplied by x. What is our x? Our x is 3 over our z. Take note, z is squared. Z is squared. So 2 squared is equals to 4. 2 squared is equals to 4. So this is going to give us, when we cross multiply, we get 3k is equals to 24. Then k will be equals to 24 divided by 3, going to get 8. Okay, we're going to get 8. So our k is equals to 8. And now we know that we can say y is equals to 8x over z squared, because we know what our k is. So the second question is find y when x is equals to 4 and z is equals to 8. Find what is y when x is equals to 4, when x is equals to 4 here, and z is equals to 8. Now you know that z is squared, so this z is squared, it means 8 multiplied by 8. Are we together? That's what it means. So this 8 and this one will cancel. We'll divide, then we'll say 4 here, 1. 4 here, it's what? It's 2. So y will be equals to 1 over 2. Okay? Then find the value of z. Find the value of z when x is equals to 9 and y is equals to 2. Now, take note here that if I can just take you briefly here, if we say, if you want to make this zx the subject of the formula, they will just swap. Y will come here, zx will be here. So it's like we're going to have something like zx squared is equals to kx over y. This is what we're going to have, isn't it? So we say z squared is equals to, what is our k? 8 multiplied by, what is the value of x that we have been given? 9 over y. What is the value of y that we have been given? It's 2, isn't it? It is 2. So now we say z squared is equals to, you divide 2 here, it will be 4. 4 multiplied by 9, what do we get? We're going to get 36. So z is equals to the square root of 36. So the square root of 36 is plus or minus 6. Okay? It's plus or minus 6. So here we're going to write 6 or negative 6. These are the answers that we are supposed to write here. Okay? So question 15. In the diagram below, ABC is a tangent. ABC is this line here. Is a tangent to the circle BDEF. Okay, the circle is here. at B, which is this point, angle DFB is equals to 40. Angle DFB is equals to 40 here. Then angle EBF is equals to 15. And DBE is equals to 45. Okay? I hope we have looked at this. Now, for me, and what I advise my learners is that even before we look at the angles that they want us to find, we can easily, going by what we learned, we can begin to work these questions out, isn't it? Applying all those rules and stuff. So if this is 15, this angle here is also 15. This is also 15. There are angles in the angles in the same segment. That's what we say. We have this one and then the other one there. This is 15. And this angle here is 45. Look at where it is coming from. This angle is coming from DE. Then this one also is coming from what? The same DE. So this one will also be 45. If this angle here is 40, look at where it's coming from. It's coming from DB or DB or BD. This one also here is equal to 40. Okay? It's very important to look at these things like that. Okay? It's very, very important to look at them like that. Then we can now find this angle here. This one. How do we find this angle? We can look at it as a triangle DBE. We already have, have something like this. Okay, this is where our B is, and this is our F, and then this is our D. So what is this angle here? This angle here, you can add these two. What are you going to get? This will be 60. And this angle here is 40. Am I right? This angle here is 40. So what do we get? This angle here, when you add this one to be 60, this one will be what? So this angle here will give us what? What are we going to get from this angle? Let's do it. What are we going to get from this angle here? I have given you the hint, so add this and that. So this is going to give us 60, 40. What is this one? So this is 100, isn't it? So this angle here will give us 80. This will give us 80. Are we together? And if this angle here is 80, if this angle here is 80, if you want, you can even confirm this. Add this and this and this one and this one. Are they going to give you 180? If they'll give you 180, then that is correct. So if this angle is 80, it means that even this one here, this angle here, it's also 80. These we call them angles in the alternate segment. Angles in the alternate segment. What about this one here? This angle, if this is 40, this angle here, the whole angle here is 40. Okay? So, having done this, then we can now try to come and find the angles that they want. D, E, B. D, E, B. Okay? Oh, D, E, B. D, E, B. This one, we have said it's 40 degrees. That's what we said. It's here. DF, or DEF, DEF, DEF. So we want this whole angle here. DEF. What is this angle? And take note, if this angle here, we said, if this is 80, then it means even this other angle here, this one, it's also 80. Okay? It's also 80. Take note of that. So, meaning this whole angle here, it's this plus this one. What do we get? 120. This is going to give us 120. So, DEF is 120 degrees. Then ABF. I think we have dealt with this one here, isn't it? What have we found? 8 degrees. Okay, that is what we have found. Let's go to the next question. All right. Okay, so we are on question 16. So given that the f of x is 2x minus 3 and g of x is 3x plus 1 over 2x plus x plus 2, where x must not be negative 2. Okay, find the inverse of f. How do we find the inverse of f? So here, like we always say, we say the first thing that you can do is to put y here, where there is fx. Then you say 2x minus 3. Then we make x the subject of the formula. So it will be plus y is equals to 2x. So to make x the subject of the formula, we divide both sides by 2. So we're going to have x is equals to y plus 3 over 2. Having done this, now we need to come and write the inverse now. So the actual inverse is going to be in this part. Where there's where there's y, we put x plus 3 over 2. This is what is going to be our answer. Now take note, the next question from this one, what we're having is the inverse of 11. So meaning here, where we have x, what are we supposed to put now? 11 plus 3 over 2. What do we get? 14 over 2. And what do we get here? 7. 7 is the final answer. So we go back, take note, we have this question here, which is a composite function. F into G. So let's write it here. So have you seen our function for G? It's here. So where there's x in G, we shall be putting what? The function for x. The function for f. So for instance, here we're going to say 3. Where there's x, what are we going to put? 2x minus 3 plus 1 over, where there's x here, we write 2x minus 3 plus 2. We go on and say this is going to be 6x minus 9 plus 1 over 2x minus 1. When you simplify these like terms here, it will give you minus 1. You go on and say 6x minus 8 over 2x minus 1. This is what you're going to get as your answer here. Okay? This is what you're going to get as your answer. So we go to the next question. Okay, so we come to question 17a. Question 17a, in the diagram below, ABC is a straight line. Okay. And the BD is equals to 12 centimeters. CB, this is CD. CD is equals to 5 centimeters. And angle BDC, here it's 90 degrees. That is what. Find as a fraction the value of sine. Find as a fraction the value of sine ABD, which is this angle here. Okay. So what are we supposed to do here? It's important that we first of all find this angle here. So how do we find this angle? We need to use Pythagoras theorem to find this other side that is missing here. To find this other side that is missing here. And when you use Pythagoras theorem to find this side here, you're going to get 13. I don't know if it's important to deal with the Pythagoras theorem thing. You just say 12 squared plus 25, plus 5 squared, that is, which will give us 25. This is 5 squared. So you have 144 plus 25. This is going to give you 169. The square root will be 13. So what is this angle here? If we are to use this one, using these ratios, and in terms of sine, you know that sine is equals to sine theta. If we call this one theta here, just an example, we say sine theta is equals to opposite over hypotenuse. So what is our opposite? Our opposite is 5. And what is the hypotenuse? Our hypotenuse is what? Is 13. That is this angle here. Okay? So here, if we drop if we have something like this one here, so we have the first quadrant, the second quadrant, third quadrant, and fourth quadrant. And sine is negative, is positive in the first two. In the fourth and in the third and fourth quadrant, it's what? It's negative. Okay? It's negative. So we are going to take it since this angle that we want, it's in the quadrants where sine is equals to negative. We are going to write this same fraction, but we'll write it as a negative 5. Negative, it will be a negative. Okay? Sorry to mention that this one, I may be subject to corrections. Yeah, you can correct me. That is if you have a different answer. I'm not 100% sure, I must mention. Okay, but I believe this is what I could, maybe there's need to research further, but this is what I could gather. I just bumped into this question, but I think this is what we're supposed to have. So please, for those of you that may have a different answer or debate, it's subject to that. All right. So let's go to the other question. So 17b, the diagram below shows a cuboid with a square base. Here it is. So write down the order of rotational symmetry of the cuboid along the given axis. The order of rotational symmetry. In how many ways can this be rotated and then maintain like the same position as if it hasn't been rotated along this axis that has been demonstrated here? So since this is going to be 4, okay, the answer is going to be 4. That is what will be the order here. Okay, that's the answer. Okay, so we come to question 18. The length L of a line is measured to be 8.1 centimeters. Correct to 1 decimal place. Complete the statement about L in the answer space below. The answer space below is this one. So all what we need here is the lower limit and the upper limit. The lower limit and the upper limit. So the first thing that we're supposed to do is to find the absolute error. Then we add it to this one to find the upper limit. And when we subtract it, we get the lower limit. So in this case, to find the absolute error here, we're going to say the least unit of measurement. We multiply by half. The least unit of measurement here is what? 0.1. So when we work out this one, we're going to get 0.05. Okay, this is our absolute error. So our absolute error, we need to add it. When you add it to 8.1, what are you going to get? You're going to get 8.15. When you subtract it, you're going to get 8.05. This is the lower limit and the upper limit. That's what we are supposed to do here. Okay? And then the second one is the mass of a bag of meal is 25.3 kg. Measured, correct it 1 decimal place. What is the relative error? Relative error is equals to absolute error over true value. Okay? So, what is the absolute error here? Absolute error again is going to be half multiplied by, we have only 1 decimal place here, so it will be the same thing as this one. So it will end up being the same one, which is 0.05 over the true value, which is 25.3. So the only thing that we can do here now is to simplify. How many decimal places do we have on the denominator? There are 2. So we can multiply this one by 100, even this one by 100. So when we do that, this is going to be 5 over 530. Because here we only have 1 decimal place, so 1 0 will remain. So we simplify here. 5 here, it's 1. 5 into 5, 5 into 3, 0. So this is what we're going to get. So write this 1 over 506. That's our answer there. Okay, we go to question 19. So question 19a, Mabwe company sold its bond to interested members of the public and paid them an interest rate of 15% per annum. How much did Mr. Hamakwebo receive if he bought a bond worth 200,000 kwacha? So here we have to find the 15% of 200,000 kwacha. Okay, so this is giving us what? 15 multiplied by 2,000. What are we getting? Can we multiply this one? What are we getting? What are we getting? This is going to give us what? 30,000. So this is how much did Hamakwebo receive if he bought a bond of. So per year, okay, per year, this is that how much this man is going to receive, okay, in terms of an interest, assuming that he's still holding on to the bond that he bought, okay, until at the point that the bond has to be redeemed. That's when like you also get the principal. Okay, so in terms of how much he got, assuming that he's still holding on to this bond, And this is how much it's going to get. Okay. B, if the equation of a straight line K is this one, y is equal to 3x minus 7. Find the equation of a straight line passing through this point and it's parallel to this one. So the first thing that we're supposed to do, what is the gradient of this one? Now in this case, the equation, once the equation has been written in this form, we know that this is our gradient. So this equation here has been written in the same form. So meaning the gradient, which is our m1, is equals to 3. Our gradient is 3. So now we need to write the equation of the line that is parallel to this line but it's passing through this point. So to write the equation of a line, this is the formula that we use. So say y minus this y coordinate. What is it? Oh, please, this is just y. This is just y here. This is just y. It's 8. It's equals to the gradient. When two lines are parallel, their gradients are the same. So m1 is equal to m2. So this is 3x minus 2. This 2 here. We have minus 8. This is equals to 3 minus 6. Y equals 3 minus plus 8. Y is equals to 3x plus 2. Okay. This is the equation that we are going to have. This is the equation that we are going to have. And this is what we are supposed to write here. Y is equals to 3x plus 2. Okay. Okay. So 20a, I have rewritten it here. Given that y is equals to 2x cubed minus 3 over x squared, find dy dx. So we want to find the derivative of this one, this function. So the first thing that we're supposed to do is to rewrite this part. Okay, to rewrite this part. When this one goes up, we get rid of the fraction part. So this will be like this. Okay. Now at this point, we can say, what is now our dy dx? So we multiply this power or this index by coefficient here, we have 6. Then we subtract 1 here. When we subtract 1, what do we get? 2. Then here we have a negative. So when we multiply this negative by this negative here, we're going to have a plus. Okay. Then 2 multiplied by 3, it will be 6. X. Now take note here, if you subtract 1, it's going to be negative 3. It's going to be negative 3. So this is what is going to be our answer. But you can rewrite it if you want to take it back to where it was, as this one will come down here now like this to get rid of the negative. So it could be this one or this. That's what will be our answer. Okay. Now we come to the second part here. Okay, so given that, the diagram in the answer space below is an incomplete program flow chart to calculate the area, which is A of triangle, of the triangle below. Okay, so this is our L here, this is our K, this is our theta. So complete the flowchart below by writing appropriate statements in the blank symbols. So the first thing that we are supposed to do is to look at this. This is a non-right angled triangle. A non-right angled triangle. What method do we use to calculate the area of a non-right angled triangle? That is why we say area is equals to, in this case now, we say 1/2. Let's just think of that formula. Okay? We multiply, say, multiply here by K multiplied by L multiplied by sine of this theta here. Sine of this theta. Okay? Sine of this theta. That's what we are going to. This is the formula that we use, isn't it? This is the formula that we use. So when we come to this table here, we have begin, then enter. What do we have to enter there? We're going to enter K and the L. Then on this part, this is processing. This is enter. Okay? And say enter. Then here we're going to say area is equals to 1/2 multiplied by L multiplied, or this is a multiplication in the computer term or language, then multiplied by sine theta. This is the this must be K. Then output area, and then end. This is what we are supposed to do. Simple as that. Okay, so 21. Write the three inequalities that define the unshaded region R on the diagram below. Okay, so we are looking at these inequalities here. So the first one is this. We can start with this one. This one cuts the what? The y-axis at 3. Oh, this is -3. This is -3. So the R, where is our R? R is on the region that is upper, on the upper part of this equation. So meaning this is the region that we want, isn't it? This is the region that we want. So R is greater, Y is greater or equal to -3. This is one of those qualities that we want. And the second one is going to be, we are going to pick 2 points. We're going to pick 2 points along this line here. So we can have 2,0, which is this point. The second point is going to be this one, which is 0,4. This is 0,4, 0,4. So we need to find the gradient of this. Okay? We need to find the gradient of this. Excuse me. So the gradient is M2. It's Y2, which is 4 minus Y1. X2, which is 0 minus X1. So this is going to give us 4 over -2. And that is going to give us, it's going to give us -2. So -2 is our gradient. So then we can write the equation using one of these points here. Remember the other part here where we were just writing an equation, where we were using this formula. Do we remember? So we use one of these. So we can use the first one. Y minus, what is the y coordinate? It's 0. Equals to, our gradient is -2. X minus 2. Y is equals to -2x plus 4. This is the equation that we are getting. Then now take note here. We need to know which part is required here. We need to know which part is required. So this part that is not shaded, where this R is found, this is below the Y. As we come here, these are less. So, and again, when you look at the line, it's dotted below, and this is dotted. So it's going to be y, okay, is less than, not equal to, because that is dotted there. Oh, this is the second inequality. The first one is this one. Second one is this one. Then we do the last one. Okay. We do the last one. So, again, the last one here, we have just to pick 2 points that are on this line. And those 2 points could be, one of them is this point here, which is 0,1. Then the other point that we can get is this one here, which is negative 2, -3. So we have -2, -3. Then again, we do the same thing. We find the gradient and stuff. The gradient now, it's m is equals to -3 minus 1. -3 minus 1. I'm sure you are familiar now. y2 minus y1. x2 minus x1. So this is -4 over -2. What are we going to get? We're going to get +2. So this is our gradient. So now we can do the equation. Y minus 1, y1. So we put 1. This is equals to, what is our gradient here? Gradient is 2. Then x minus, what is our x coordinate? 0. Y is equals to 2x plus 1. This one has to come the other side as a plus. Okay. Then now, if we are looking at this, which part now should we consider? Okay, this part below here, as we come down, these are less. Okay, this is less here. And if you want, you can use this point that is here to test, yeah, because this must be less, isn't it? This must be less. And the line is solid. So we're going to say now, y is less than or equal to 2x plus 1. Okay? So this is the third what? Inequality. It's the third inequality. Okay. So this paper constitutes 23 questions. Unfortunately, my question paper doesn't have the last 2 questions. Okay, I think I lost the pages that have those 2 questions, question 22 and question 23. I'm sorry about that, but we have done 95% or 98% of the work. I think those 2 that were only quadratic functions as well as trivial graphs. Okay, but we have answered 21 questions of this paper. Please don't forget to get in touch just in case you have got questions to make. I don't mean to give me questions to solve, no. Just in case there's a mistake that we've made and you want us to correct. Because I receive a lot of hundreds of requests to solve questions. No, it doesn't work like that. We have a lot of work to do. Okay. Just unless you want us to, if you want us to get into some kind of business arrangement, not just to solve. We have a lot of stuff to do. Okay. Thank you very much for watching. Look out for other videos that we have prepared. Okay. Goodbye.